And the quad-core turbo is going to get you to 3.06 away from 1.6 gigahertz. These are great products. And who is better to talk about this cool CPU than a cool guy? Probably one of the coolest at Intel. He wears this strange hat. He talks in a funny accent. Funnier than mine, I bet. I would like to call Muli Eden, the General Manager of PC Clienting, and the Vice President. I'm Muli.
Funny accent, do you want us to elaborate on it?
Sure.
Have you heard your TH?
I erased all the ages from all my kingdom.
One correction, this is not strange and it's not a head, it's a breath. But let's go on. So first of all, good morning everybody. I'm delighted to be over here and to be part of the introduction of Clarksville. We'll try to take a sneak peek over here, very fast, and elaborate it later on. At 11:30 we'll have a deep dive for those of you who would like to go into the schematics and into the broad diagram and understand what we have. So what do we have over here? We've got several technologies. We've got, first of all, the Intel Turbo technology, and you heard Dadi say, guys, it's a 2 gigahertz, but with turbo it can go to 3.2. And I believe this is the first time that we actually spoke about the frequency. More than 1.2 gigahertz, and you kick the microprocessor in order to run faster. Hyper-threading technology, in order to be more power efficient, rather than doing one thread at a time, each one of the core can run 2 threads in parallel, get a much better efficiency, utilize all the resources. So now in class we've got 4 cores and 8 threads. An integrated memory controller on top of the 8 cache, which is a smart cache, 8 meg level 3 cache with level 2 with level 1, because the locality of the cache is not good enough. In addition to all this huge amount of data that we store on chip, we need to have a wider bandwidth to go to the memory to feed all these mix-hungry cores with all the data that they need to do. So these are the 3 technologies. Let's have just a sneak peek, as I said, because we'll cover it much brighter into the turbo technology. What do we mean by the turbo technology? We've got 4 cores. Let's say that the TDP thermal design power of the 4 cores is 40 watts, each one of the cores is 10 watts. We used to work with the 10 watts, measuring it, and this was the frequency. Today we actually measure the actual power dissipated. And if the cores are not utilizing all the resources, that are not using the divider or the multiplier or any part of the resources, the measurements say, yes, there's 10 watts, but it doesn't use all the 10 watts. You can boost up the frequency and the voltage in order to get better performance. So we've got 2 bins, each bin 133 megahertz, 2 bin 266 megahertz, and even a quad core, if all the cores are working, you can get a boost. If we switch off 2 cores, now you can take the headroom of the power which is not used by the 2 cores and move them over to the 2 functional cores. This gives us an extra 8 bins. I believe according to the script, this is the stage that I need to be quiet and you need to say, wow. So let me repeat, 8 bins. And if, thank you. Can we do a rehearsal? This was not part of the script. And if you switch one of the 2 cores and stay with 1 core only, you can get an extra bin to run it out. And the reason it's only 1 and not more, there's a limit how much we can crank the voltage up due to reliability. So we take everything, and I believe the bottom line of the measure is the following. The Clarksville is the best quad core, dual core, and single core microprocessor, because we always take the extra headroom and move it to the cores. I can continue to talk about it for a long time, we will do it in the 11:30 session, but I need to run forward, but I will just need to leave you. If you are leaving with one thing about Clarksville, about the Nehalem architecture, it's the turbo, which was great in desktop, but even much more so in notebooks because of the limited power headroom. Now, what are we going to do with this product? Quad-core, hyper-threading, 8 threads. It's a great gaming machine. I believe you'll see all the gaming machines that exist over there. You'll see multimedia engine. If you want to do some heavy duty, definitely this is the right thing. And last but not least, it's a mobile workstation. If you want to have a workstation, guys, it's called mobile, it's called workstation, but it says the power of a server of 1.5 years, 2 years ago.
You're talking too much.
You are right. You are right. Don't laugh. This was also.
I was in idle mode, low power, up until now.
So, as this is IBM, that is right. I was ready 4 minutes on stage with without a demo, what do we see over here?
So you're talking about ultimate gaming. This is the ultimate gaming mobile platform right here by Alienware, showing our Clarksville XE part.
So this is Clarksville already ready to ship system, gaming system.
Absolutely.
What do we see over here?
So we're seeing Resident Evil 5 by Capcom. It's one of the most popular games out today, and also one of the most violent.
This is popular. This is what our kids play with.
Absolutely.
I like these zombies, you know.
Is there something less violent, a little bit more?
Yes, two things are selling, you know, violence and...
Only, stop here.
Okay, so for the geeks, we've got something nice, you know, we take a lot of pictures, we stitch it together, and there's a lot of myths running here.
And a nice music.
And a nice music, and you can see all the threads are working, and because the 4 cores are working, but they are not utilizing all the compute power, the small ingredients inside the core, we can even have the kickoff of turbo boost. We're going from 1.6 to 1.83, and the minute few of the cores will be idle, and you'll see that some of the cores will be dormant, immediately the rest will kick off in order to finish the job. And with this in mind, in order not to take too time, I'll bring the baton back to Dadi that made me swear that I'll not take it with me backstage, although I had this temptation. Thank you very much, gentlemen.
Thank you, buddy.